I need to start Verilog. Okay. Yeah. I need to start Verilog. Okay. One second. Give 1 minute of time. We'll start. Start. Okay. As per your request, I'm starting the Verilog classes. Okay. Yeah. So Verilog, I'm starting the Verilog. Okay. RTL design. So yes. Okay. See here. Basically, so Verilog. So this one, I'll rename this Verilog. Okay. I think you can see this Google board. Okay. Microsoft Google board. I'm sharing the screen. Okay. Yeah. Yeah. 1 second. Yes. Yes. Okay. So see here. Basically, Verilog. Okay. Okay. So Verilog. Introduction to Verilog. So basically, if you see programming languages, there are two types. One is software programming languages, software programming languages. Okay, programming languages. And next you have hardware descriptive language. Hardware descriptive language. Descriptive language. Okay. Software programming languages are nothing but like C, C++. Okay. And next Java, Python. Okay. Java, Python. Okay. And in hardware descriptive languages, you have so you have what we call Verilog, and next VHDL. Okay, Verilog, VHDL, and system Verilog. System Verilog also we can use for the designing as well as verification. Okay. So basically, what is the difference between this this one? That means software programming languages and hardware descriptive languages. So software programming languages means what? This will develop the application. Means they can develop the application, but they can't create the hardware. They can't create the hardware. They can develop the application, okay, by using Java, C++ or Python. They can develop the application, and that application we can use for banking sector or any like commercial or any like what hospitality. So that applications they will develop by using this high level software programming languages, and this is sequential. Sequential means what? So whatever the programs are there, that will be executed, instructions will be executed serially. Okay. And here this hardware descriptive languages, so this hardware descriptive languages are we can generate the hardware, we can generate the hardware. Okay. There is a thing called like synthesis. Okay. Synthesis. By using synthesis we can generate whatever the program we are writing in HDL into gate level netlist. Gate level netlist. What is gate level netlist? Gate level netlist is nothing but it is in terms of the whatever the circuit is there, that is there in terms of gates. Okay, so that is gate level netlist. Okay, so here if you see, so I'm not talking about this software languages. Our main aim as a VLSI, so our main focus is this HDL. Okay, hardware descriptive language. Okay, so HDL, hardware descriptive language. So what is this HDL? I think in digital you already studied combinational circuits, sequential circuits like adder, subtractor, multiplexer, sequential circuit like D flip flop and count as registers. So there you know the functionality, but how you are describing, okay, how you are describing, so describing in textual format, okay, describing the hardware. HDL is nothing but describing the hardware with textual format, with the textual format is nothing but HDL. Okay, so in HDL again there are two types: VHDL. VHDL is nothing but very high speed integrated circuits, hardware descriptive language. Okay, very high speed integrated circuit, hardware descriptive language. Okay, and so here this one is VHDL is used for high security, and it is used for defense purpose, in the defense and or we can use it in the academics. Okay, we can use in academics. Okay, suppose here if you see like Verilog. Okay, Verilog, so this came into like into this we are using that means people are using from 1999 they are using this Verilog VHDL. Okay, and Verilog, so Verilog is basically it will follow the old languages like Ada and Pascal. It will follow this old language. Okay, so that means code is it's a complex. Okay, it's means whatever the syntax and whatever the other, it is difficult to learn. Okay, and code will be complex. It will follow the old languages. And Verilog, it came into picture around 2001. So there is the IEEE, okay, Institute for Electrical and Electronics Engineers. This IEEE, they made this Verilog language as a universal, and so this is like a majority whatever the corporate in the total world, we are using this Verilog. Okay, so basically it will follow C syntax. If you are comfortable with C, so you can easily learn the Verilog. Okay, so Verilog. Okay, so that means here so Verilog basically we are using for this one. And next, system Verilog also we are using for design. So we are using 30% for design, 70% we are using for verification. Okay, verification. This Verilog also we can use. Okay, so like Verilog also we can use up to FSM. We can write the test bench for by using Verilog. Suppose large systems are there like SOC, system on chip, or large IPs are there. Okay, large intellectual property ICs are there. So with Verilog it's not possible to verify that circuit. We can design the Verilog. Okay, so there is a like in RTL design that I will discuss. What is this RTL design? So by using RTL design, we are designing that circuits. So if complex circuits are there, we need to go for what? Verification. Okay, so for verifying that circuit, so what is verification? Suppose if you take full half adder circuit, you know that A and B, so sum is 0, 0, 0, 0, 1, 1, 0, 1, 1. You know this. So that means sum 0 carry 0, sum 1 carry 0, sum 1 carry 0, sum 0 carry 1, sum 0 carry 1. You know this. But how the circuit will know? You need to write the code, design as well as test bench. Okay, you need to code as well as design as well as test bench. Okay, test bench to verify that circuit. Okay, this is about the basic introduction to Verilog. Okay, any doubts in this? So that I will move forward. Yeah, anyone give response? Yes. Okay, next you see. Yeah, next. Yeah, so here so you know that like so why you are using Verilog? That means this Verilog and so here first what you will do, suppose you have a full adder circuit. You have a full adder circuit. Full adder circuit means what? Full adder circuit, it consists of what? You know that sum equal to what? Sum equal to A XOR B XOR C in. Okay, and carry equal to what? Carry equal to AB plus BC in plus AC in. Okay, so that means what you will do? You will draw the so how you will get the circuit? That means A B C, you are getting sum equal to this value, and you are taking this A B and BC. Okay, BC, so these are connected with AND gate. Okay, AC in. Okay, AC in, these are connected with AND gate, and these are connected with what? OR gate. Okay, these are connected with OR gate. You will design like this. Okay, so here what I will doing for this full adder, so you need to write the code. You need to write the code, Verilog code. Okay, describing in textual format. Okay, so after that, this you are writing in what? EDA tool. EDA tool. Okay, so what is EDA? EDA is nothing but electronic design automation. Electronic design automation. Okay, so why you are using electronic design automation? Suppose here 100 transistors are there, we can do the schematic, we can draw the schematic. Okay, like 10 to 100 transistors, 100 modules are there, like 100 modules are there. We can draw manually, we can draw the schematic. But like suppose 1 lakh modules are there, in that 1 lakh modules are there, and some millions of transistors are integrated with that modules. Okay, that modules are integrated with the help of that millions of transistors. Manually it's not possible. There EDA will come into picture. Okay, so this EDA, by using this EDA we are writing the program. So basically we are using Xilinx Vivado. Okay, we are writing the Verilog code in Xilinx Vivado or Quarters Prime. Okay, so by using these two we can generate the circuit, we can elaborate the circuit. Okay, you can generate the design. Okay, elaborate the design, and model sim is there. Model sim. So model sim, basically this will write a Verilog code. We can simulate by using model sim. We can simulate. Okay, and one more Quasta sim is there. Quasta sim is also simulation software. We can write basically this Quasta sim, we can write Verilog code. Basically this is used for writing SV as well as we call as UVM. For UVM and SV we are using this Quasta sim. Okay, so these are some EDA tools. Tools. So what these EDA tools will do, when you write the program, this EDA tools will convert whatever the program, whatever the Verilog code into gate level netlist. Verilog code into gate level netlist. Okay, so that means what is gate level netlist? You are describing the circuit. Okay, describing the circuit in terms of what? Describing the circuit in terms of gates. Okay, so that means here we designed this full adder using NAND gate, NOR gate. We designed, no? So we implemented. So that means it is in terms of gates only. Okay, so that means as I told you, so converting the code HDL code, okay, into gate level netlist. Gate level netlist gate level netlist is called what? Synthesis. Okay, you are converting your code into gate level netlist. It is called synthesis. Okay, so here you have high level synthesis also, C++. There you are using C++. This is high level languages. Okay, high level languages. This high level languages you are converting into what? It will be converted into Verilog, and Verilog will be converted into gate level netlist. Okay, so this is about basic introduction to this, what is synthesis, and why you are writing the Verilog code, and so basically what are the EDA tools. Okay, basically I will tell you with Xilinx Vivado as well as Costasim also. I will show you how to write and how to write that programs, that I will tell you. Okay, is there any doubt in this? Give response. Yes, no. Should I move forward? Am I audible? No? Yes. Next you see. So, representation of design. So, what is this representation of design? Okay. Representation of design. Okay. So, representation of design. So, there are 4 representations are there. So one is switch level modeling, and gate level modeling, and data flow modeling, and next is hybrid modeling, behavioral modeling. Okay, behavioral modeling. Okay, and next hybrid modeling is also. Hybrid modeling means we can write the program by using both data flow and behavioral modeling. That is hybrid modeling. So basically, wherever you are writing the program in data flow and behavioral modeling, that is nothing but RTL. Okay, RTL is nothing but what? Register transfer level. Okay, this shows how the data is transmitting in the register. Okay, so basically what is RTL design? We are writing, so that means this will be convert. This can be synthesizable. Synthesizable means what? This can be converted into hardware. That's why we call as RTL. Okay, register transfer layer. Okay, RTL. Okay, so here first if you see basically first if you see the basic switch level means what? Switch level means you are writing in terms of what? Basic CMOS transistors. Okay, so you can write the Verilog code for CMOS transistors. Okay, so if it is CMOS, so here what you are using, this is this is PMOS, this is NMOS, and this is a basic CMOS inverter circuit. Okay, so you are giving A, you are getting A bar. Okay, so here A, so this is VDD, and next this one is y equal to A bar. Okay, so this is nothing but basic transistor level. When you are writing the Verilog code, that is nothing but switch level. Okay, so this is very complex. Suppose modules are made with so many transistors, when you write with the switch level, it is becomes very complex. Okay, so that's why we are not going with the switch level. Okay, and next gate level modeling. Okay, gate level modeling is nothing but what? Gate level modeling is you are writing, so you are using some gate level primitives. What are the gate level primitives? So they are predefined words. Okay, in the Verilog you have 150 150 predefined words are there. Okay, 150 to 200 predefined words are there, like module, end module, okay, and or. Okay, you are using gate level primitives like and, or, XOR, XNOR, okay, XNOR, and NAND, NOR. Okay, so how the syntax will look like means, gate level primitive, gate level primitive, okay, gate level, that is primitive, and instance name, and output, and these are the inputs, okay. Suppose if you take one simple AND gate is there, okay. So let us take the primitive is what, A1, okay, instance is A1. So let us take the inputs are what, A and B, and y equal to what, A and B, okay. So how we are defining, that means gate level primitive. What is the gate level primitive? And what is the output? Y, output y, A comma B, okay. Here you can use instance name also. So what is that instance name? Second, so instance name is so and A1, this is instance name, okay. So this is the instance name, okay. This is gate level modeling, okay, gate level modeling. And next, if you see the data flow modeling. So data flow modeling means what, you are representing in terms of what, data flow modeling in terms of expressions, okay. Data flow modeling you are representing in terms of expression, okay. So you need to use a continuous assignment statement, that is the assign statement, okay, assign. Suppose like same AND gate I will take, okay. So if I write with this one, y equal to A and B, no. So in data flow modeling, how I am writing, assign, okay, assign y equal to what, A and B. I need to use a continuous assignment statement. This is continuous assignment statement, okay, continuous assignment statement, and I am writing this one, okay. This is data flow modeling, okay. Suppose if you take half adder circuit, what are the inputs? A, B, and what are the outputs? Sum and a carry. So 0 0 0 1 1 0 1 1, okay. 0 0 1 0 1 0 0 1, okay. So you got sum equal to what, A XOR B, no, A XOR B, and carry equal to what, A B, okay. So this one if I want to write in data flow modeling, A and B, okay, A and B. So I will use assign S equal to what, A, this is the symbol, okay, bit level XOR operation, okay, that we will discuss. Assign A XOR B, assign C equal to what, A and B, like this I need to write, okay. So this is data flow modeling. And next is what, behavioral modeling. So behavioral modeling is nothing but what, suppose so what is the next one, behavioral modeling, no. So behavioral modeling, yeah, so behavioral modeling, yes, behavioral modeling. Suppose if you take the half adder circuit, so there are two inputs are there, and sum and carry, okay, sum and carry. So 0 0 0 1 1 0 1 1, I will get 0 0 1 0 1 0 and 0 1, okay. So this is my half adder circuit, okay. So here behavioral modeling means I know the behavior of the circuit. What this will do? This is a 1-bit adder. It is consist of 2 inputs and 2 outputs. So it can add. So that means it can add. Okay. I will not bother about the internal circuit. I will not bother about internal circuitry. So that we can write in behavioral modeling. Okay, so in behavioral modeling you are using like that is behavior of the circuit. Okay, no need to bother about the internal circuitry. I can use the behavior, with the behavior of the circuit I can write the program. Okay, so basically you are using this initial block, okay, and always block you are using in the behavioral modeling. Always block, okay, always block. Initial block this is non-synthesizable. Basically in the test bench we are using this one, and this always block is synthesizable, always block. And we can use some procedural statements also. What are the procedural statements? Procedural procedural continuous assignment, procedural assignments. What are the procedural assignments? In the behavioral modeling you can use like if else, okay, case case statements, okay, you can use if else case statements, while statements, loop statements. So like this we can use in the behavioral modeling. Okay, hybrid modeling means we can combinely, hybrid modeling means we can use both data flow as well as we can use behavioral modeling, hybrid modeling, behavioral model. What is hybrid? What is the meaning of hybrid? Mixing. Okay, mixing is nothing but hybrid modeling. Okay, and next this is about basic designs in the behavioral modeling. What is switch level, gate level, data flow modeling, different types of modeling styles in the Verilog. Okay, data flow modeling, behavioral modeling, and hybrid modeling. Okay, next, is it fine? Shall I move forward? Any doubt in this? Yes. Okay. Okay. Verilog code will once again tell me, sir. Only tell about, sir. Okay. Okay. I will go slowly. Okay. Yes. So this is about the different modeling styles. And next you see. So next, basic syntax. Basic syntax in the Verilog. Okay, so basic syntax in the Verilog. So Verilog will start with the module. Okay, the predefined keyword. Okay, these are the keywords: module and end module. Module and end module. These are nothing but keywords. What are these? Keywords. Okay, module and end module. It will start with module and end module. Okay, we need, so this is case sensitive. Verilog is a case sensitive. Verilog is a case sensitive. Case sensitive means you need to use lower case only. You need to use lower case only. Okay, case sensitive. Okay, so what are keywords? Keywords I told you, around so if you Google it, what are the keywords in Verilog, you will get around between 150 to 200 keywords you will get. These are predefined words which are in a standard library. Okay, these are keywords. Okay, what are these keywords? Keywords. Okay, keywords, these are predefined words which are in standard library. Okay, so here suppose if you are writing for half adder, so if you see the block diagram, this is the half adder circuit. How many inputs are there? 2 inputs are there. Let us take the inputs are AB, and how many outputs? Sum and carry. Okay, sum and carry. So how you can write module, half adder. Okay, half adder. Next you have port list. Okay, so here this module is nothing but what? Keyword. Module is nothing but keyword. Okay, HA is there, no? This is nothing but identifier. Okay, so what are the port list? So that means here semicolon is there. So what are the port list you have? How many ports? How many variables you have? So 4 variables you have. So that is port list. You can give A, B, S, okay, and C. S and C. Okay. These are the ports. Okay, and here semicolon will be there. End module. Okay, end module. End module. Here no semicolon. No semicolon. Okay, this you need to remember. Okay, so code will be like this. Code will be like this. Simple half adder circuit. Simple half adder circuit code will be like this. Okay, so this is basic syntax for Verilog. So if you see, suppose like rules for identifiers. What are the rules for identifiers? Rules for identifiers. Okay, so what are the identifiers? We already seen. What are identifiers? Here HA I given, no? HA. This is nothing but identifier. Okay, HA I gave. That is nothing but identifier. So so we'll see what are invalid identifiers and valid identifiers. Invalid identifiers. Okay, invalid identifiers, and next valid identifiers. Okay, invalid identifiers and valid identifiers. Okay, don't worry, I will share this. You need to install the Microsoft board from the Play Store. That is this one. From here, from store, you need to install. I'll share the link so that you can open this content. Okay, what are the invalid identifiers? H space A. There should be not space, no space. Okay, and next 2H A. It should not start with number. Okay, and here see 2HA, 2HA, and next it should not start with dollar $HA. Okay, and they should not have a special symbol H hash A. Okay, H hash A. Okay, so from this, what you can say, we cannot use the special symbols, okay, special characters. What are not allowed? Special characters. Okay, characters. Numbers at starting position. Numbers at starting position. Numbers at starting position. Gaps in between. Gaps in between. These are not allowed. Okay, special symbols, numbers in starting position, and numbers in starting position, and gaps in between. Okay, these are not allowed. And what are valid identifiers? It can, compiler will take HA and H small a, HA2, okay, and HA small HA2 it will take. Okay, like underscore HA it will take. Okay, suppose if you are writing for 2x1 mux. Okay, so if you use like 2x1 mux, if you write module like 2x1 mux, this one is 2x1 mux, and this is the port list. Okay, it will not take. Okay, so in order to remember this, you will follow this one only. No, you will write like 4x1 mux in digital, 4x1 mux, 16x1 mux. You will write like that only. So that means here this will not take. Okay, this will not take. So how we should give? So here how it will take? Module underscore 2 cross 1 marks you can. Now the compiler will take. So underscore, so that will start with underscore. The compiler will take. Okay, and next you have HA underscore H underscore A. These are available. Okay, is it fine? Okay, yes. Okay, next you see. So these are the rules for identifiers. Okay, invalid identifiers and valid identifiers. The invalid identifiers are nothing but it should not start with number, special character. There should be not space, no space between the letters. Okay, those are invalid identifiers. Valid identifiers means HA, H small a, HA2, small HA2, underscore HA. Okay, HA underscore, H underscore A. It will take. Okay, and next if you see port list declaration. What is this port list declaration? Before going to the programming, you need to know about this basic concepts. Okay, step 1. Okay, there are two styles are there. Okay, there are two styles are there. Those are so I'll explain you style 1 and style 2. Style 1. So what is the style 1? Let us take module. I'm taking half adder only. I'm taking the example of half adder. So this is half adder. How many inputs? 2 inputs, A, B, and outputs are sum and carry. Module HA. Okay, A comma B comma sum comma carry. Whatever the port list are there, that you are defining in the bracket. Okay, next port list are defining the bracket. Next, especially you are initializing the inputs. Input A comma B, output what is that output? Output sum comma carry. Okay, and so you can write end module. Okay, there is no space, end module. Okay, this is style 1. If you see the style 2, module HA, input A comma B, output sum comma carry. So you are declaring the inputs and outputs within the bracket itself. Okay, inputs. Okay, inputs end module. Okay, so these inputs are there. The inputs and outputs. Okay, input. Okay, not input, output, and some signals are there. In out are there. Those are acting as both input and output. Those are in out. Okay, so input port as well as output ports. These are the keywords. These are nothing but keywords. Okay, you need to remember. Okay, so these are the two styles. Okay, first style is nothing but you are displaying means whatever the port list in the bracket, and separately you are declaring the inputs and outputs after this module. Okay, and second style is you are declaring the inputs within the bracket itself. Okay, so basically you prefer this one. Okay, so basically we'll define within the bracket only. Okay, so next basic constructs. What are the basic constructs? We see the basic constructs. Okay, suppose dollar display is there. Okay, these are some system task. Okay, dollar display, dollar monitor. Dollar display is nothing but suppose in the C language you are using printf, no? printf, whatever you are printing within the double quotes, okay, that will be printed. Same like that, here you have dollar display, okay, dollar display. In this dollar display you have blank if you want blank space, you can use backslash b. Suppose if you want tab, okay, tab, you can use backslash t, okay. If you want to display in the new line, okay, so you can write backslash n, okay. These are nothing but basic constants. And comments, okay. So comments are very much important. Suppose in the industry, so they will write the comments for each and every code, okay. So why? Because the employee will be available for 2 years or 5 years. After he left the company, other person will come, other person should understand his way of approach and idea, okay. So comments are very much important, and with the comments only you can understand the logic of that instruction, okay. So why comments are there? This will increasing the readability, okay. This will increasing the readability, okay. And understanding lines which are not executable by the compiler. So that means when you are writing the commands, this will not executed by the compiler. Compiler will understand that is comment, so that will skip, okay, okay. Suppose module example is the module example, okay. So here module example, I can write single line command means 2 slashes a plus b, okay. So this can be skipped by the compiler. Okay. So comments are single line comments, okay. So what is the syntax for single line comments? So you can write like this one, okay, single line comments, okay. So here again, so this will be not compiled by the, this will skip by the compiler, okay. This will not compile it, okay. So like this single line comments, okay. Multiple line comments, suppose it will be start with slash star, and some multiple lines are there, it will end with the star slash, okay. So these are nothing but multiple line comments, okay. So multiple line comments, it will start with the slash star, okay. Nesting of comments is not allowed. Nesting is not allowed. So that means comments under comments, okay. Comments not allowed, okay. This is not allowed, okay, okay. And some operators are there. So operators, we'll discuss more about operators. Some operators are there. So what are these operators? Operators are first unary operator. Unary operator is nothing but one operand. There will be one operand only there. Suppose not of a, okay, and this one operand with and of a, okay. This we will see about unary operator. And next only one operand. So that means this is operand, okay. This is nothing but what? Operator. Okay. Binary operator means two operands will be there. So like a and b, a or b, Okay, ternary operator means three operands will be there. Okay, three operands means C equal to A question mark B or C. So that means if C equal to A, so if A equal to 1, condition, if A equal to 1, C equal to what? B. Okay, otherwise C equal to what? C. Okay, here I can use Y also. Okay, where you are using this ternary operator means, suppose if you consider 2 cross 1 mux. Okay, 2 cross 1 mux is there. So 2 cross 1 mux, you have two inputs are there, no? This is I0, I1, and what is the output? Y, selection line. Okay, so here Y equal to S. Okay, which one will be connected? I1, otherwise I0. So what is the meaning in this? If S equal to 0, Y becomes what? I1. Else, this is like condition only. Else Y equal to what? I0. Y equal to I0. Okay. So these are the basic operators. Okay. So this is about today's session. So today's session we started with the basic Verilog programming. So here we seen the basic what is the introduction to Verilog programming language, software programming language, hardware programming language, what is the difference between software and hardware. Okay, and what is VHDL, Verilog, system Verilog. Okay, these are HDLs. Okay, what are HDLs, and what is synthesis, we already seen. What are EDA tools, how many types of EDA tools are there. Okay, and how many types of modelings are there. Okay, switch level modeling, gate level modeling, behavioral modeling, and hybrid modeling. Okay, with examples I explained. Okay, and next basic syntax we have seen. So how the Verilog code will look like, it will start with module and end module, and some rules. So this is like module, identifier, and port list. So some rules with identifiers, like so identifiers, invalid identifiers are nothing but it will not start with a number, or should not have the space in between, and should not have the special symbols. So these are the valid identifiers. So there are two styles of portlet declaration, like ports are declared inside the bracket, and separately need to initialize the input and output. This is style 1. Style 2 is you can initialize within the bracket itself. Okay, basically we will refer this basic constructs. Okay, like we are using display, $display, some $display, some system tasks are there, we will discuss that. $display, $monitor, $strobe. Okay, $finish. Okay, these are system tasks. So it's same as printf in C we are using, no? So like if you want blank space, backslash b, tab, new line, comments. So comments means it will increase the readability. Single line comments, multiple line comments. Okay, single line comments will start with double slash, multiple line comments will start with slash star slash star. Okay, operators, you see in unary operator, binary operator. Unary operator, one operand will be there. Binary operator, two operands will be there. Ternary operator, three operands will be there. So ternary operator means I told you with one example, that 2 cross 1 mux. Okay, so this is about today's session. Yes.